Hi, so today we're going to be talking about sequences of rigid transformations and congruence. So go ahead and please open to page 49 in your book. So first off, our learning targets for today is we're going to learn how to perform a sequence of transformations on a figure, just kind of like we did yesterday, but again, with a little bit more added to it. And then we are going to understand that a sequence of rigid transformations can change the location and the orientation of that final image. So again, it won't ever change the size or the shape, but it can change the location and the orientation. So we have our first problem on page 49. And so we see that Kamani and Jake each perform two transformations on this figure T here, but not in the same order. So we are going to start with Kamani's sequence. So she started by reflecting across the y-axis. So that is this right here. So she reflected along this line, which means all the points are equal distance. So this point is 5 away from this line of reflection. So we're going to go 5 the other way. 1, 2, 3, 4, 5. This point is 7 away from the line of reflection, so we're going to go 7 this way. 1, 2, 3, 4, 5, 6, 7. This point is 5 away, so we're going to go 5 away from the line of reflection. 1, 2, 3, 4, 5. And this point is 7 away from the line of reflection, so we go 1, 2, 3, 4, 5, 6, 7, like so. And then we connect our dots, so that would be the very first t, so in other words, t prime. But after it's been transformed one time. The next part is that she translated 4 units to the left. So we're going to take our t prime and translate them 4 to the left. So we go 1, 2, 3, 4 from this point. 1, 2, 3, 4 for this point. 1, 2, 3, 4 for this point. And 1, 2, 3, 4 for this point. Then we connect our dots like so. And since this is our second transformation, so we had this transformation went here, and this transformation went to here, this will be t double prime. So t with our 2 prime notations like so. So that's what Kamani's looks like. Jake, on the other hand, he started with a translation of 4 units to the left. So we're going to start back over at t and go 4 to the left. So from here we go 1, 2, 3, 4. For this one we go 4 to the left. 1, 2, 3, 4. This point we go 4 to the left. So 1, 2, 3, 4. And same for this point. 1, 2, 3, 4. And then again we connect to get our first transformation for Jake's sequence. So this is t prime for Jake because it's our first one. Then he reflected along the y-axis. So he reflected across the y-axis, which means he was 1 point away here, so now he's 1 point away here. He was 3 points away here, so now 1, 2, 3 here. 1 away here, so 1 there. And 3 away there, so 1, 2, 3 here. And that gives us t double prime for Jake. So again, that's t, and then we put our 2 prime notations. And so will both sequences map t onto the same final image, so we can see that Jake's final image is this one here in orange, and that Kamani's final image was this one here in blue. So we would say, no, they are not mapped the same place, because one is here, and the other is there. So this is what it looks like in the picture it, which is what we just kind of went over on page 50. So this was Kamani's. So first they reflected, then they translated. So that was their final image. And Jake translated and then reflected. So here was his final image. So we can see there are two different spots. We could also look at it by the model it, so by doing it algebraically. So if our original coordinate was at 5, -2, and we reflected along the y-axis, that means that our x is going to become its opposite for each of these here. So 5, -2 is now -5, -2. 7, -1 is now -7, -1. 7, -7 is now -7, -7. And 5, -4 is now -5, -4. So again, when you reflect along the y-axis, that means all of your x values are going to become their opposite. From there, they translated 4 units to the left, which means you're going to take each of your x values and subtract by 4, since you're going to the left 4. So -5 minus 4 is -9. -7 minus 4 is -11. -7 minus 4 is -11. And then again, -5 minus 4 is -9. So these were the final coordinates for Kamani. Jake, on the other hand, he started by translating 4 units left. So you're going to take each of your x values and subtract by 4. So 5 minus 4 is 1. 7 minus 4 is 3. 7 minus 4 again, 3. 5 minus 4 is still 1. So this is the new coordinates. And then he reflected, which means you take each of your x coordinates in this column and make them their opposites. So +1 becomes -1. 3 becomes -3. Again, 3, -3. 1, -1. And all of these values stayed the same. So -2 stayed -2, -1 stayed -1, etc. And so we can see that these coordinates are different than these coordinates, which is another way that we know that they did not end up in the same place. Now we're on the connected portion, so that's on page 51. So again, they ask, do both sequences map figure T onto the same final image? And we would say no. The picture shows that both final images face the same way, but one is farther than the other. And the model shows that the coordinates are different as well. Also, for part B then, we have how do you know that both final images are congruent? And so we know that they are congruent because they do not change their size or shape. Because remember, anytime you do a rigid transformation, it will not change the size or the shape. It might change the location and it might change the orientation, which is the direction that it is facing, but it will never get bigger or smaller, and it will never change its shape. Now we have number 2 here, where we have to translate this figure 3 units to the left, and then we reflect the image across the x-axis and draw the final image. So again, we're going to start by translating it 3 units to the left. So take each of these points and go 3 to the left. 1, 2, 3. 1, 2, 3. 1, 2, 3. And this one goes 1, 2, 3. And then from there we connect our dots. So this is our T prime. Then he reflects it along the x-axis. So reflect along the x-axis. So then this is 1 away, so it's going to be 1 right here, because remember we're reflecting it along this line. This is 2 away, so we go 2 up here. This is 4 away, so we go 4 up here. And this is 7 away, so we go 7 up here. Notice that they don't change their x-coordinates, they only change their y-coordinates when we reflect along the x-axis. Now we're going to perform these same transformations but in reverse order to draw our final image. So we will start this time by reflecting the image along the x-axis. So this time we start with this one. So we start here for this point is the same distance. This one's 2 away, so it's also 2 away here. 4 away, so 4 away here. And then 7 away, so 7 away here. Then we connect these two. Then, remember, we're going reverse order. So this time, we are going to go ahead and go 3 units to the left again from this shape. Then we go to the left 3 for each of these. So 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. And if we connected the dots, we would see that it lays right on top of this figure, just like how we had the other one. So we did part B, and then it says, do both sequences map figure T onto the same final image? And we say yes, and we know because we just practiced both of them to the side over there. So both of them ended with this image here. So this would be our T double prime for both, if we did it the regular way or the reverse way. So in this case, they do end in the same final image. However, that is not always the case. So yes, just like I said, the vertices of both final images have the same coordinates. So they do indeed make the same final image in this example. Next, we have question 3, which says, what can be different about a figure and any of its images after a sequence of translations, reflections, and rotations, and what always stays the same? So what's different could be the location and the orientation, or in other words, the direction it's facing. So like giraffe, it might suddenly be here and goes to here, and then it could be facing a different direction. However, you'll notice it doesn't get any bigger or smaller, and it doesn't change its shape. So it's still a giraffe. It didn't become a rhino. A circle didn't become a square. It didn't get bigger or smaller. It just changed its location and the way of spacing. Next, we have number 5. So this is page 52 now. And we are going to use what we've learned so far to solve these problems. So we're going to rotate this figure W 180 degrees around the origin. So again, we have this. We're rotating it around our center right here, origin, and we're doing 180 degrees. Remember, when you do 180 degrees, you're making your X and Y their opposites, which could be written algebraically like this. So we have our first point here, which is at 1, 0. So now it's going to be at -1, 0. We have our second point here, which is at 2, 2. So now we're at -2, -2. I'm going to connect these. And then we have this point here, which is at 3, 0. So now we're at -3, 0. Because remember, 0 can't be positive or negative, it's just 0. We have this point here, which is at 4, 4. So then we go -4, -4. And then this point that I forgot, so at 0, 4. So now it is at 0, -4. So this is this first 180 degree rotation around the origin. Next, it's asking us to translate the image. So now we're going to translate it up 4 units. So we're going to take our new figure and translate all the points up by 4. So this one up 4, so we'll go up here. So 1, 2, 3, 4. This point up 4 is 1, 2, 3, 4. This point up 4 is 1, 2, 3, 4. This point up 4 is 1, 2, 3, 4. And this point up 4 will be right here. And then we connect our dots here. So then we have to see what new letter did we form, and we formed the letter M after we rotated and then translated. And is our new letter congruent to the original? We will say yes, because remember, it did not change its size or its shape. It just changed the way that it was facing. So it changed its orientation and its location. So we would say that M is congruent. Remember, this is the symbol for congruent to W. So remember, the symbol for congruent is that equal sign with that little squiggle on top. Next, we have question 6, which asks, a sequence of transformations is performed on a figure, then a different sequence of transformations is performed on the same figure. The resulting images are not in the same position. Can they be congruent? And again, yes. Any rigid transformation, no matter what order, no matter how many times you do it, will never change the figure's shape or size, and therefore it will be congruent. So again, no matter what order you do the rigid transformations and no matter how many rigid transformations you do, it will never change the size or the shape. They will always be congruent. The last problem we have here is number 7, and so we start by translating that figure 3 units to the left. So again, we're going to translate it 3 units to the left. So we'll take each of our points and go 3 to the left. So 1, 2, 3. 1, 2, 3. Connect those. 1, 2, 3. Connect those. And then 1, 2, 3 to make our Z prime because it was transformed once. After that, we are translating that new figure 5 images down. So remember, your new figure could also be known as an image, which is after it's been transformed somehow. So now we're going to translate that new image 5 units down. So we'll take each of the points and go down by 5. So we'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Which gives us our Z double prime. Next, we are going to perform them in the reverse order. So this time we are going to start by translating it 5 units down from our original. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And finally 1, 2, 3, 4, 5. And connecting that. In this case, in our reverse order, this will be our Z prime. So now our second step, remember we are going in reverse order right now, is that we have to draw it 3 units to the left. So now we are translating 3 units to the left because we're going in that reverse order. So then we go 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And so we can see this image also ends up on our Z double prime, how we had it originally. So, do both sequences map figure Z onto the same final image? We would say, yes, the vertices are indeed the same because they both end up, no matter if you do it this way or if you do it the reverse order, you still end up right here. So yes, the final images are both sequences in the same location and have the same orientation. Lastly, your homework is going to be pages 53 and 54 in your book. That's going to be due Friday at 9 a.m. They look like this here. So you're going to translate figure A from that first example down 6 units to form figure D, and then you're going to rotate figure D 90 degrees clockwise around the origin to form figure E. And then you're going to see, does the sequence of transformations map figure A onto figure C that they have in the example above? From there, you are going to reflect triangle DEF right here across the y-axis, which is right here. From there, you're going to rotate it 90 degrees counterclockwise and label the coordinates of your final image as well as show it in here. And for question 3, you have this figure here. You're going to translate it 8 units to the left to form figure A prime. Then you're going to reflect that across the x-axis to form your A double prime. And then you're going to describe whether or not figure A, the original, and figure A double prime is congruent and how you know. And then your last problem is you're going to perform these sequence of transformations on this figure here. So first you're going to rotate it 180 degrees around the origin to form your H prime, J prime, K prime, L prime. Then you're going to reflect it across the y-axis to get your H double prime, J double prime, K double prime, L double prime. And then you're going to reflect it across the x-axis to form your H triple prime, J triple prime, K triple prime, L triple prime. And then you're going to write what the coordinates are of the vertices of your final figure and how do the vertices of your final figure compare to your vertices of your original figure. So again, you rotate 180 degrees, you reflect along the y-axis, and then you reflect along the x-axis. And that is your homework. If you have any questions, please let me know. Other than that, goodbye.